Hello and welcome to my third devlog video. In the last video, I talked about scripting, but I didn't actually show any scripting. Well, in this video, I will. Over here, I've created this floating island type thing. It's not supposed to have any relevance, but you know, it's something. And over here in this pedestal, I thought of adding a puzzle. And so we're going to do this together. And I can show you the workflow with my tool here. So if I want there to be some interactable area here, I hit edit, add interactable, and it appears at my position, but you can see that we don't see it. So you can't see that we have it. Over here it's created it, called it interactable 4. This doesn't mean that there's 4 interactables, but that it's the 4th game object, so that they all have a unique name. You cannot call it something like puzzle 1 or something like that. And the reason we don't see it is because the Z layer is behind. But this is just for us, since the interactable element is actually invisible in game unless debug mode is on. So you can select a zone of interactability, let's say this, and where Ian will go if he interacts with it, which I'll say right here. And now we need to say what script it should load. And I'm going to load a script called test puzzle1.lua. Now we haven't created this file yet, but I will momentarily. Now that I have placed my interactable zone and that I put in my file to be executed here, I can save the project and I can start actually creating the file. So over here, I have a folder here. This is where I said I'd create the script. So I'm going to create a document and call it the same as we called it in the editor, which is puzzle1.lua. And there you go. I'm going to open this with a text editor. You can use anything. I'm going to use mousepad, which is basically my notepad. I would suggest to use something that has colors when you program in it so that you don't get lost. So when you interact with an interactable, the first function that it will call is a function reaction. So if I write function reaction here, I suggest learning a bit of Lua if you want to follow on with some of the syntax. I'm mostly going to be showing my engine specific syntax. But here, this function is the first to be called. Anything that's in between this zone will be ran. So if I write print hello world and save it, when I go back into the game and click this, it'll print hello world in the terminal, of which I will demonstrate now. Also, I plan on adding in stairs so Ian can actually go up, because right now he just goes left and right and ignores that slope. But that will be in the next devlog. No matter, if you click on this, he'll actually still go to the X coordinate, but not the Y coordinate, and he'll still interact with it, which is something I plan on changing. Nonetheless, when we click on this, it says hello world. Next, I'm going to actually create a puzzle. Well, less of a puzzle and more of a mini game. TicTacToe to be precise, or actually, cheese and crackers from the game Pajama Sam. Well, this is obviously a little joke. It will still help us to see how the scripting works in the engine. And while I'm at it, I guess I could teach a bit of Lua. This isn't supposed to be like a tutorial or anything, but whatever. I think looking up on how Lua works and all that will help because, well, it's in Lua. But I'll explain more in detail the game engine specific codes that I've added to the language. Nonetheless, let's first figure out how we can make this game. Well, I'm thinking of making a 2D list that has some vertical and horizontal coordinates, so that we first identify the column and then, well, first the row and then the column. This will be 0, 0. This will be 2, 2 as coordinates. So let's start by creating that list. And also, instead of programming it in Mousepad, I'm going to use another program called Atom. Atom allows for these more advanced colors and mini maps and stuff. There's plugins and stuff, but you can use anything like Sublime. Just something that has, it just makes it easier to write. You don't need these tools, but they help. But before we do anything, we require something very special. We require this line of code. This tells Lua to use these files over here. Well, this file specifically, but this file then requires these two other files. What this does is allows us to have what this allows us to do is use things like input over here to identify the keys. So instead of writing key 4, we can write input.key A so that we know that we're talking about the A button. That way you don't need to learn all of these numbers. Alright, let's start. First of all, I'm going to create a comment here. A comment is a piece of code that isn't executed so that I can write anything as a comment. I like to create my variables at the top. So I'll identify my variables here, and then I'll create them below. I'll first create a variable called grid. This will hold the grid of the game. This just means that it's a list. Later on, I'm going to define the size of the list, specifically in the reaction. So over here, I've created a 3x3 array, basically defining our x and y within these two square brackets here. What this does is also it sets all the values to 0, and then we could set them to 1 for an x, or 2 for a circle, or 1 for cheese and 2 for crackers. And I create this in the reaction itself. Though I don't have to create it here, I could also create it over here. Or in fact, creating a function for it. That way, all I need to do is call the function. Alright, so far we've only been creating Lua specific code, but right now I'm going to start writing some Hyper Game Engine specific code. Now there's no documentation just yet, but I plan on adding it once it's more complete. These two lines of code here are quite interesting. The first one, this .script set playable, makes Ian unplayable. Or actually, it allows us to set if Ian is playable or not by putting in true or false. If we set it to false, this will disable any and all of Ian's input, so you can't move him at all, unless now in this script we define our own motions. This is how I did the dog run before, allowing me to use W, A, S, and D without moving Ian in the same time. So important to note that set playable is only for Ian, not the game itself. I plan on making this not a part of this .script, but for now, this is how it works. The next one I will keep in this .script, and it's set update. This will make the script updatable or not. It is set to false by default, and if you set it to true, it will look for a function called update and continuously, update the function. This allows us to create some looping code while the rest of the game continues to play as normal. I'll create this function now. Over here you can see in the parentheses of this function that I've put in input and dt. These are two parameter variables. The first one, the input, is for, any input, any press of the key, any click, is all stored inside this variable. The next variable is dt. This is for delta time. Now, delta time is the amount of time in between every frame, and that just allows you to do a bit of mathematical multiplication to smooth out motion, if that makes sense. Basically, instead of making your player move to the right 3 pixels per frame, you can set your player to move 3 pixels to the right per second, which means if the game is running at 60 frames per second and then it goes to 30 FPS, 30 frames per second, that he won't go half speed, he'll go the same speed because there's more time in between every frame per second. Did that make sense? Anyway, to make that simple, just multiply by delta time and everything should work out. I said this wasn't a tutorial. Alright, so if I were to print out this is updating. That's how you write it. Updating. I can't spell, whatever. This is update. There you go. If I do this and I execute the program, by the way, ignore these errors, or they're temporary, and you can see that the game does not crash. This is a selling point. So if I click this, you can see that this update just fills in the terminal, and I can't click anywhere. I cannot move at all. This is a good thing since this is what we programmed, but we've kind of soft locked the game now, and the only way to escape now is by either closing the game with the X or hitting escape. Now before we go any further, I'm actually going to define a few variables here. Over here, I've defined a resolution X, resolution Y, and scale. This is going to be when we actually create the entities with the textures, the sprites of cheese and crackers and all of that. So I'm defining right now that these images will be 32 by 32 pixels, but I haven't actually created the images yet. And over here, SCL is for the scale. So if 32 pixels is too small, I can put a 2 here, and then they'll take 64 by 64 pixels. So this is just for defining size and making it easy to retain correct aspect ratios. Now with a square, it's not really complicated, but nonetheless. Right now I'm going to create a function that's going to add an entity to the world. I'm going to call it add cheese. So over here, you can see that I have a function called add decoration. This is very similar to if I were to go into the debug mode of the game. Here, edit add decoration. So clicking this button actually executes that function and creates a decoration item in the world. And you can see here size, res X, res Y can all be defined here in code. So this function will create and add a decoration to the world with this name. This can be anything that you wish. I'm going to call it cheese because it's going to be a piece of cheese. Next up, we have a vector3f. This is simply 3 floating points that define a position. X, Y, and Z. Z being the layers, of course. So I'm just going to put it at 0, 0, and 50. So that way, we'll probably see it. Over here, we have the res X, res Y, and scale variables that I've defined up here. You could put the numbers directly, but this is why I wanted to use them here, because I'm going to be using them with the cheese and the crackers, so might as well use both of them here. They're not going to change. And finally, we have this string of characters. Default, what's that? Well, this is where we define the sprite, but not the path to the sprite, not the image itself, but what we've called it when we loaded it. Default is a preloaded texture that's simply a grid. And right here, when we create the grid, I'll add a piece of cheese just like that. Now if I run the game normally and go to our little puzzle scene, hit the interactable location, and we have a little itsy bitsy tiny teeny weeny grid. Now that's not the grid of the game, but the default texture. Alright, well it worked, and it just so happened to be in front of Ian. But this here is in global coordinates. That means that it's 0, 0 is never really in front of Ian at all times. To make sure that no matter where we place this game, it always ends up in the right place, we're going to want this to be relative to Ian or the interactable location itself. Luckily, we have some code to do this. Over here, I'm going to define an X and a Y coordinate that I'm simply going to plug in here. I'm going to set X to this dot entity. This is the interactable location itself. And that entity, you can then use commands that you can use with any other entity. So the cheese, the crackers, the grid, any entity that we've created, Ian, the map itself, every entity has these commands inside. So I can write get transform to get any information relevant to his transform. That is the position, rotation, scale. And I'm going to get the position by writing get pos like this. And then I can simply define the coordinate that I want, which is x. And I'll simply copy and paste this for y. And switch out the y. Now that we've done this, if I go back into the puzzle scene and interact with our little blue zone over here, you'll see that it spawns right in the center of that interactable zone. And this is good because we can now place any tic-tac-toe game anywhere in the world. We can have many of them and they'll always be at the correct position. But right now we've only have one cheese and we don't even have a texture for it. So let's create that real quick. Alright, now that we've created our cheese and cracker images, we need to load them into the game. We do this by executing the game in debug mode, and over here, giving them a name. I'm going to call the cheese cheese in all capitals, and input the location here. And the path is res, textures, test, cheese and crackers, cheese.png, and you hit add. And then I'm gonna add cracker in just the same way, and I hit add. And we can check in our list here to make sure that they're added, and indeed they are. Now, to make sure that these changes are saved, we do need to hit save. I plan on adding a separate save option because this forces us to save an entire scene. Now, I'm just gonna save the scene, delete me, hit save, go here, and we can delete del me. So now our changes are saved in the resources file here, and that means that we can actually use the textures. So instead of loading cheese as default, we'll load cheese. And when we decide to click our little interactable, we can see that a lovely piece of cheese has now appeared in the center of the button. Now it is a bit small, but we can fix this by simply changing the scale here. I'll put it to 6. Let's try it out. Oh whoa, now that's a big piece of cheese. Maybe a little too big. I'll half it for now. Next up, I'm going to add a little function that adds crackers. This function will be very similar to the cheese, so I'm just going to copy paste it and change cheese for cracker. Now when we decide to add a cracker instead of a cheese, we can see that a piece of cracker appears. Excellent, everything is working out just fine. Now we need to actually make sure that these are placed in a grid of sorts. So how are we going to do this? Well, I suggest that we're going to add the x and y coordinates directly into the cheese itself and the cracker itself as well. But these coordinates won't be their absolute coordinates, these will be relative coordinates. And in fact, I won't call them relative, I'll call them grid x because that's where we're really placing them, inside a grid. Now, before I continue with this, I want to point out something. The name that you give the entity is the same name that you can see over here in debug mode when I add a decoration. Instead of calling it decoration 1, it's going to call it cheese. The problem is, once you start creating another entity, it needs a unique name. But if you call two entities cheese, you'll no longer be able to select the second one, only the first one. This is because when the game looks for an entity called cheese, it goes through the list of all entities and stops once it finds one. which means that basically once it's found this one, it doesn't assume that a second one even exists. If you're in a problem like this, you can simply quickly add an underscore or something, and you can see that this fixes the problem. Just make sure that your entities always have a unique name, because I was too lazy to implement a system that could detect two entities with the same name. Nonetheless, this is a problem if we're going to consistently add cheese with the same name. It'll add it, but then we'll no longer be able to interact with it. To fix this, I'm going to give it a unique name that is its name followed by its grid X and Y position, since there can only really be one cheese or cracker at any one location. Now I can do this by concatenating the numbers with the string, and you can do this in Lua by adding two periods like this followed by the variable grid X, and then I'll do it again with the value grid Y. So this is not going to be called cheese anymore, it's going to be called cheese grid X grid Y, which could be cheese 0 0, cheese 1 1, cheese 2 2, and actually, according to our little diagram here, we're going to, because of the way Lua works, we're going to make this over here be coordinates 1 1, this will be 2 1, and this will be 3 1, and this will be 3 3. I put 2 2 before, but Lua likes to start at 1 instead of 0. That's important to note. So this cheese here would be called cheese 1 1, and this cracker would be called cracker 2 1. Good, we've solved our unique name problem. Now to actually place them at these locations. Well, here we've put in the parameters grid X and grid Y, but we're not doing anything with it. Now we could simply add grid X and grid Y, but the problem is that these positions are in pixels, not in grid. So I'm going to have to define the size of the grid. I'm going to do this here with all my other variables. I'm going to call it grid size, and I'm going to make it equal to res X times scale. Now, I could have used res Y or res X because they're the same number. Basically, it's a square. Now, this won't work. Do you know why? It's because here I'm using the variable res X, but we only define it down here. So it doesn't exist here because code is read from top to bottom. This means that all of this code needs to be above so that we can use these variables. Alright, now that we've defined a grid size, I can use it over here by multiplying by grid size. So this way, we're offsetting. Basically, I've told Lua that this here is 32 pixels. So if I want to place a cheese here, I say place it at 32 pixels. If I want a cheese here, it'll add another 32 pixels because it's going to do 2 times 32. And then here, same goes, it'll do 32 times 3. Now, a little problem with this is that the cheese is most likely going to be put at the lines instead of the center, but we'll offset it if anything. It's just the grid is going to be a bit wonky to start off with. And I'm also going to copy and paste these little mathematical stuff here. So now, if I were to add cheese and crackers, we would also need to define the X and Y within the parentheses here. I cannot say that word today. So here I'm going to add a cheese at 1 1, then a cracker at 2 1, and a cheese at 3 1. This is what it should look like. Cheese, cracker, and another cheese. Well then, let's find out if it worked. Whoa, would you look at that? It did! Now you can see that it's offset a bit, as I've stated before, but the cheese and the crackers are placed one next to each other, just as we've anticipated. Now the reason that it's going diagonally towards the right is that little offset I was saying. So it's offset a bit towards the right and starting here because we're doing 1 times 32 and the center is at 0. We'll fix that later. It's also doing the same thing in the y. Nonetheless, if we were to put the coordinates 1, 1, 2, 2, and 3, 3, we should have a diagonal line. And you can see we do, though that last one is kind of going far. And also, it's going upwards instead of down. Well, I'll fix this real quick. It does make sense that y going up would go upwards, but it'll be simpler if we do it the other way around, I think. But that's just me, I don't know. So instead of adding the y, I'll subtract it. And wouldn't you know, bam, it's going the other way around. Excellent, our little grid system seems to be working quite well. Now let's put it back in the center. I'm going to do this by a little more math. Well, if we know that we're starting at 1, the first thing we can do is perhaps subtract 1 to grid X and grid Y before placing it. So I'll do this, and we should be 1, 1 should be the center of the blue square. So at least 1 cheese should be in the center of the blue square. There you go. A little more offset done. Now we want the center of the grid to be in the center. So we know that right now this here is 0, 0. This cheese is at the center. And we want it to be over here. Well, we do know the size of an individual square. So if we offset X and Y by 32, 32, we should have the center of the grid. Let's try that. And we're going towards the right and then downwards, which is positive X, negative Y. So I'm going to be making it actually move towards the left. The entire grid is going towards the left, so we want to subtract X. And we want the entire grid to go up, so I'm going to add Y to 1 grid size. Right, if I do this, now everything should be centered. Excellent, there we go. We have a centered grid. Now to make the grid a little easier to see, I'm going to create a grid tile. This tile won't be very complicated. I believe a simple square should suffice. Just like that. Maybe the opposite. I like that. Perhaps all of this can be that color. There we go. And I'm going to export this as tile. And just like our other textures, I'm going to go into this editor, call it something. I'm going to call it CNC underscore tile for the cheese and cracker tile, and go to the path, of which is very complicated for the moment, so I'll just go here. There we go. So it's res, textures, test, CNC, tile.png. I hit add. I make sure it's there. It is. Excellent. File, save as, delete me, save. And I'll make sure that I just remove this file. Not very important. It's empty. And I'll close the program. And now what I'm going to do, I'm going to add in another function to add a tile. This is simply for aesthetics, just so we can see. It'll have the same code as the cheese and the crackers, except that the name is going to be tile, and it's going to use the CNC tile. I can't quite remember what I called it. CNC tile. Alright, we named it good. And I'm going to add tile over here where we're creating the values. Simply going to add a tile at the coordinates I, J. Since this is going through a 3x3 array, it's going 1, 2, 3, 1, 2, 3, 1, 2, 3 in X and Y, and it's going through every possibility, every combination. So we can add a tile at every location, just as we're setting the value to 0 at every location in the actual grid of the game that we'll be using very soon. Nonetheless, if I were to execute the game now, click on the little blue square, we have ourselves a little grid. Now, I can't see the cheese and a cracker. This is probably because the tile is in front. I'll make sure to remove one from the Z layer. And I can do this by simply going over here and putting 49 or something, some arbitrary number. And let's see how it magically works. Wow, look at that. A high quality, modern looking, pixelated cheese and crackers game in a Brutal Moose fan game. Well, there's no game yet. We should probably get on that. Now, we have a way to add cheese and crackers visually, but we're not actually taking them into consideration for anything. Right now, we have this value here, this variable called grid. What is it doing? Well, right now, grid isn't doing much more than holding in a grid of information. This grid right now looks a little something like this. It's a big box, a 3x3. It's a big box of boxes. A 3x3 grid, and inside every box is a number. Over here, I set this number to 0 for every box. So it's just being written in just like this, one row at a time, just putting in the value 0. Now we could tell our code if 0 is inside this box, it means nothing's there. And then we could set it so that it says 1, and that 1 is an X, or a cheese, or whatever we want it to be. And that a 2 is a cracker, or a circle. They look the same, nonetheless. This way we could then check if any row has a row of the same number. This way we can verify who the winner is. We also want to make sure that we check diagonally and all these other combinations. First things first, I want to add a ability so that we can click and it can tell us where we've clicked. And I think I know someone who can help us with that. First of all, in our update function over here, all the way down here, I'm going to add in a little bit of code. You can see that these lines of code are quite long, and what they do is some more crazy mathematical things that are way too complicated and that I should probably add functions for later on. Just take it for granted that this will store in values for the mouse X and Y in the world. So it can tell you where you're clicking in the world. Now I actually need to create these variables, and I'm going to create them all the way up here. Alright, now that I've created them up here, I've set them down here. I'm now going to use them. I would like you to meet my little friend, Axis Aligned Bounding Box, or AABB for short. Now this function can tell you whether or not two squares are intersecting each other. I'm going to be using it to check if the cursor, a small square around the cursor, is intersecting with any of our tiles. Now you can see here I'm already using mouse X and mouse Y as parameters for the A square. And for the B square, I'll be using an entity called B, of which I'll define when I actually call this function. This way we can use the same function to check if we're intersecting with a tile or another tile, which tile. Now to make this easier, I'm going to add all these tiles in their own list of tile entities. And well, I'm not really going to complicate my life. I'm going to call it GridTile Entities. This will hold the list of all the grid entities, not the game itself. And this will just use the tiles as collision boxes, basically. And we can do this over here in Add Tile by simply writing GridTile Entities, square brackets, and here we want to say where in the list to put this tile. Luckily for us, I have a function for this. Table length is a function that's going to tell us the length of our table. This is what Lua calls them because they can be used for a whole bunch of things, or tables. They're very different from arrays. I know I've been calling them arrays, but I'm not used to it just yet. Nonetheless, if we put in our GridTile entities into the table length function that I've created here, it'll tell us that this has a size of 0. And then we'll add 1 to say, okay, well, at the first position, we want to add, well, this tile here. And then it'll have a length of 1. And so when it adds the next tile, this will give us 1, plus 1, 2, and so at the second position, we'll put in the next tile. And then to get the tile, we're going to have to make this equaled to get entity. Nope, not get engine, get entity. And in quotation marks, the entity that we want, which is tile grid X, grid Y. And there we have it. We are now putting every single grid tile inside this list. Now, in the update function, I'm going to create a little loop, a for loop that goes through every single tile and checks whether or not the cursor is intersecting. And we can do this by doing for I equals 1, comma, and then the table length of our entities here, GridTile Entities, and for every entity in that list, do this. And what is this? Well, it's simply AABB, open parentheses, and put in GridTile Entities I in square brackets to say for this one in a list. It's just a for loop. I really don't know how to explain it. Sorry. Anyway, for every entity in this list, we're checking if it's intersecting with the mouse. But we're not doing anything with this. AABB is spitting out true or false, and we really don't know what's going on. So we're going to put it in an if statement. If we're intersecting with one, then do this thing, maybe print intersected. This way we can know if we've intersected with anything. And in fact, I'll say that we've intersected with, and put the I so that we know which one we've intersected with. 1 being the first one, 2 being the second one, 3 being the third one. This is the first one, the second one, the third one. This would be the fourth one, fifth, sixth, etc., etc. So if we were to execute this, click on our little blue square, and I'll move this so you can see the terminal, nothing is printing out. But as I put oh, there we go, it says intersecting with 1. I'll put my mouse on the second one, it says 4, oh, okay, it's going downwards. 1, 2, 3, and then 4, 5, 6, 7, 8, 9. Not exactly the order I thought it was. I think I did something in a bit of the wrong order, but that's okay. Anyway, this works, but you can see that it's consistently checking. To optimize a bit, I'm only going to check once we actually left click. Now, to check for any input, this is really simple. You write if input, which is the variable over here, dot get mouse down if you want to check if we've just clicked. If you want a key, you get key down. If you just write get mouse or get key, it's going to check like for motion. So it's not like just one type. It's going to be consistent. But now I just want to check if I've just clicked. And with which button I've clicked. This is where I use input all in capital letters dot mouse left button. And then I'll write then we do all of this and I'll just, there we go. So if we press the left mouse button, we check at where we're intersecting, and everything is beautiful. So now if I were to intersect, if I were to intersect over here, if I click on this, oops, I've seemed to have miswrote something. Oh, here, we don't want input dot get messed down. It's like this for functions. It's a colon. My mistake. Alright, so now if I try it again, we have our grid, and you can see that nothing is being printed as my mouse goes over, but when I click, it says we've intersected with 1, 2, 3, 4, 9, 8. So it's detecting correctly. And we can't intersect with 2 of them at the same time, which is pretty important. Alright, next up, the ability to actually place cheese or crackers. So instead of printing here, I'm going to put in a comment that says place cheese or cracker here. But how do we know if cheese or cracker should be plain? Well, because it's called cheese and crackers, I think cheese should go first. And I'm going to detect this with a function, with a variable. So I'm going to create a variable called cheese turn, and I'm going to set it to true. So if it's cheese's turn, this is true, and if it's cracker's turn, this is set to false. So over here I can check if cheese turn, then place cheese. I called it add cheese. Alright, add cheese. But where do we add it? This is yet another problem, because we've only detected it's the tile that we've clicked on, but we don't exactly know where it is just yet. But don't worry, we can get this quite easily. Okay, well, maybe there's a better, more optimized way to program this, but for now I'm just gonna make a big if statement. Alright, I think this should do the trick. Basically, I check if I is... oh wait, no, I forgot. This should be the opposite. Hold on. There we go. So if I is 0, because, well, or 1 actually. So 1, 2, 3, 4, 5, 6. So I check if I is equal or less than 3, which is anywhere over here. I just set y to that number. So 1, 2, or 3. And I set x to 0, but it should be 1. So I'll make sure that this is all, there we go. Then once you're over 3, but smaller or equal to 6, that is to say over here, I set I equaled to, I said y, I equal y to I minus 3. So it's not equal to 5, it's equal to 5 minus 3, which is 2. So that's the correct y. And then I just set the x to be 2. And then same thing for everything else. It goes over here, it subtracts it by 6, so it uses these numbers. And then I manually set 3 as the x. So this should all work. And over here, we'll add a cheese at the coordinates xy. If it's cheese's turn, else we'll add a cracker at xy. Alright then, let's give this a shot. Hopefully everything works and I didn't make a mistake. Oh yeah, I forgot that we had these. Hold on. There we go. I just removed the little test add cheese and cracker that we had over here. So now we should have a completely blank grid, and we'll see if clicking works. So we have our grid, and when I click, it adds a piece of cheese. If I click somewhere else, ooh, it still adds a piece of cheese. But it is adding the cheese at the correct location, which is what counts. The reason that it's not switching is because once cheese places his cheese, we don't tell it to switch. So if it's cheese's turn and he places down the cheese, it's no longer his turn. And if it's cracker's turn and he places down his cracker, then it's cheese's turn. So as we click over here, we should see that everything should be working. We add a piece of cheese, we click again, and we have a piece of cracker. So just like that, we have cheese and crackers. Except for one thing, there's no way to detect who won, and you can place your cheese over the cracker. Or under it, it would seem. Same for crackers. So if cheese were to play in the center, hold on. This means if cheese were to play in the center, and then cracker clicked on the center, it just places it at the same position. I think it's finally time for us to detect where we're clicking and actually set things straight. Now we can do this because we've created our grid variable, and it's finally time we use it. So this is a two-dimensional array, which will probably make it a lot easier to detect. I'm not too sure why I didn't do that with the tiles themselves, but you make mistakes sometimes. Nonetheless, over here, we have a grid ij, we'll put in xy, and then if this is correct, if not, I need to reverse xy, we'll see. I'll set this equal to 1 just for testing. I'm not going to do it here though. I'm going to do it after we've added our cheese or cracker. And then I'm going to check here. I'm only going to add a cheese or a cracker if there's nothing there. This is just for testing, of course. So let's see if this works. So what I've done now is just made it impossible to click at the same place, except that there is a mistake. Hold on. Here it should be 2 equals, sorry. So now I should have made it impossible to click at 2 locations, or two people to click at the same location. So I can click here. I've made a mistake. This should be 0, because we only want to be able to place things where it's set to 0. Right, so what I'm doing now is I'm checking if the location that we've clicked on the grid has nothing. And then if it does have nothing, we add a cheese or a cracker, and then we say that there is now something there, which means if we attempt to click again, it'll be set to 1 and not 0, and we won't be able to place a cracker down. So if I try to click here, it adds it. If I click again, hey, it doesn't add it. And it forces me to click here, and then cheese can't add it, so cheese can only click there. There we go, we're getting somewhere. But now, of course, we have no way to check if it's a cheese or a cracker since all of these are set to 1 now. But this is simple, really simple to fix. Basically, I'm just going to move these so that it's easier to see. If it's cheese's turn, we want to say that it's equal to a 1. And if it's cracker's turn, we want it to be equal to a 2, just as we've said before. So now this is what's happening, all of this again. So all these are equal to 0, and then once somebody places something, it's equal to a 1 if it's a cheese, and it's equal to a 2 if it's a cracker. And if somebody tries to place, it checks if it's a 0. If it's not a 0, it means somebody already placed something. So it has to be a 0 to be able to place something there. So by changing the 1s and the 2s and all of that, it doesn't change anything for us right now, but now we can finally write the code that detects who's won. So here I can place a cheese, not a cracker, place a cracker, not a cheese, and they can only place 1 after each other. Excellent. Alright, well, that means the only thing left to do is to detect if anybody is won. I'm going to create a new function for this, over here. I'm going to call it check if won. And I'm going to do this every time somebody places down a cheese or a cracker. So over here, I'm going to check if somebody's won. Now, how are we going to do this? Well, we're going to be using similar code to the creation of the grid itself. But instead of creating the grid, we're simply going through and checking every part. So instead of doing this and adding a tile and all of that, we're checking if grid I j is equal to something. So over here, we're going to set winning conditions. Now, I'm not exactly sure right now on the top of my head what could be the most optimal way to detect this. But we basically want to see if 3 consecutive grids elements are the same number. Basically, I'm thinking first there's going to be a loop where it's going to check if this one, and then this one are the same. If they're not, it goes to the next row and checks if these 3 are the same. If not, it goes to the third one, checks if they're all the same. If they're not, it'll then go on every column, so it's going to check if these 3 are the same. If not, it's going to check if these 3 are the same. And then finally, if these 3 are the same. Then the last 2 winning conditions, I'll just add manually to check if these 3 are the same and if these 3 are the same. I'm going to start by creating a variable over here. I'm going to call it I'm going to call this variable last number, and I'm going to equal it to 0. Then I'm going to check at a certain point the last number needs to be equal to grid I j. We probably want to do this after. I'm actually going to set last number to -1 so that I know that if it's equal to -1, it means that it's the first time it's checking. There is no last number, since -1 can't exist. I'm gonna start by checking here what it's equal to. I'm gonna say this number is equal to that. Well, we'll start with that. So if the last number wasn't a -1, I'm like figuring this out like in the moment. All of this I literally programmed live. Well, live. I didn't live stream this, but I did not prepare. So if this number was equal to the last number, then we're good. Else we're not good. And so I can create another variable here called same numbers is equal to false, or is equal to true, and then if they're not the same, then it's equal to false. So we've lost. Well, we haven't won. So here we can also check if it's not equaled, just like that, something like this. So yeah, this seems a bit complicated, but you know, it's whatever. Basically, I'm going through 3, and I'm checking if the last number is not the first number, is unset, and then I'm checking if the two numbers are the same. If they're not the same, then they're different, and that means cheese and cracker, they one block the other. Otherwise, it's going to be true, which means over here, if same number, then win, and I'll add a win function here. So function win, and here you can put in an ID for who won. So 1 for cheese, and 1 for cheese and 2 for cracker, and then we'll just put in the last number. So if all 3 are the same, that means somebody won, the one with the last 3 numbers being the same. And then we'll do something here, like we'll print, like if ID is equal to 1, then cheese won, and then if ID is equal to 2, then cracker won. So this is doing 1 row. It's doing it's checking like this. So it's doing 1, 2, 3. Are these 3 the same? If they're not, it continues, and it does these 3. If they're not the same, it continues. It does these 3. And if all of that isn't true, then I'll add in a second for loop. I think I forgot an end. There you go. And then I'll for all of these. But here I'll add a J here and an I here. Reverse the I into J. The code should stay exactly the same. And this will check if this code will check like this. If anybody's won like that. If not, check if people won like that. If not, check if somebody won like that. Alright, that's like more than half of it done. I think we should test this right now, just to check if this works, because it's all very abstract right now. I'm not. It's the first time I programmed TicTacToe. All right, so there's a mistake somewhere. This is one of the worst things. So right now with the engine, if you've written something wrong, it will say attempt to call a nil value, and it won't tell you where. I'm thinking right now it's this win function that I can't put here below the win when I'm calling it, and that it needs to be here. I'm gonna check if this is it. If it's not this, then you're gonna have to give me 10 minutes. I'll cut it, of course, so you don't have to see my suffering, but hopefully that was a mistake. That was not the mistake. Okay, let's figure out. Alright, I figured out what the mistake was, and it's all the way down here where I just put this extra end here when I was adding this end. That's because this, oops, is a part of all of this. I don't know how how this has happened. Nonetheless, this should all be back to normal. And we can actually check now if it works. So hopefully now I've fixed everything. Alright, so that's all good. Okay, so let's try this. Cheese, crackers, and cheese. Cheese won. Now the game doesn't stop, so crackers can click here and then cheese and crackers both win. But hey, it actually worked. Alright, so if I try it this way too, cheese, crackers, cheese won. Alright, so far so good. That's 2 out of 3. And I have it programmed diagonally, which means if we click here and go diagonally, nothing happens. Alright, so now we want to check if somebody has won diagonally. And we're going to do something similar to all of this, except for the fact that we're really just... Well, we're actually just going to do this. Yeah, exactly. We only need 1 now because they're going to be the same. Going to create those 2 variables here. We're going to say, yeah, we're going to copy this here. Just like that. But instead of checking ij, we check ii. So now we're going diagonally. Perfect. So that's 1 diagonal. And we'll end it with our last diagonal here. But instead of being ii, we want to reverse one of them to be 3 minus I, or 4 minus I, because it'll be 1 at the minimum. So that's 3, then 2 is 4 minus 2 is 2, and it can be 3, which is 4 minus 3, which is 1. Exactly, good. And just like that, I believe we're done. Just gotta add our little win check here. That should be everything. So we're gonna do our last tests here to make sure that everything still works. Horizontal, vertical, and diagonal. Jeez. Ooh, it did not work. That is interesting. So it didn't work top to bottom. So maybe we're missing one. Thought it'd be okay. Turns out not. Let's try it like this though. Oh, dude, I just found out what the mistake is. Oh man, it took me like 20 minutes too. Okay, so the mistake isn't anything to do with how the values are created or anything like that. Look at this, look at this. I used J here, and J doesn't exist because I'm using I. It's 2 times I. There you go. 100% that fixed the bug. Same goes for over here. It's an I, not a J, because J didn't exist. Because that was literally the point of doing it like that. Hold on, that's not good either. This should be 4 minus I. So, yeah, you want to make sure that you know a bit of programming. I'm sorry, I'm tired. Anyway, yes, so the reason the value was nil was because I was setting it equal to ij, and j didn't exist, so obviously it didn't get a number back. So now if I click this, like this, bam, oh it works, bam, oh it works, and bam. Why? I'm so confused. What else could possibly be going wrong? Why is this an S? Stop adding S's. Was it originally an S? It was originally an S. Okay, hold on. It's because like this is confusing. This is a good time to tell you that it's very important to assure that your variables have easy to remember names that don't confuse other people and don't confuse you. Because not things like this happen. Okay, last number. Okay, I think now everything is good. There's probably like another mistake that I'm not even aware of. Oh, look at that. It said that the cheese won. And if the cheese wins, I win. And if, I was gonna say if we all win, everybody wins. That's not true. I guess, I don't know. Can I go this way? I cannot. What? Wait. Huh? That's what? So that was a mistake. That you wanted like that. Yeah, that was probably. So over here, you do this, you do this, you do this, and cheese wins, and that is great. And there we go. We're done. Everything works. Oh my gosh. So you go here, you can do diagonals. Guess I'll show the diagonals after. You can do horizontals. You can do bloody verticals. Bam, bam, bam. Cracker one. Alright, so all of this is great, but you can notice that every time I always need to like close the game and all that for two reasons. One, because once somebody has won, like this, let's say cheese wins, well, you can keep playing. So like that kind of defeats the purpose. We need to stop the game and we need to give control back to Ian. So we can do this. Well, first we'll give control back to Ian by taking our code that we have up here, these two, and putting them in the one over here. So once somebody wins, which is over here, you want to set Ian to playable and updatable to false. We can actually keep the game updating if ever there is like something that you wanted to continuously update even once you leave. But for this, we're gonna set everything to just kind of stop updating and all that. So here we're playing, we can't go anywhere. Then we can go, oh, I can play now. Not exactly what I wanted to happen. That's weird. Oh, because it checked that's really weird actually. That means in one of these areas, huh? Oh, because, okay, what it's done now is it checked, that's funny, it saw that at some point the three squares, one next to each other, were equal to 0. So it didn't, so it said basically, it thought that 0 won, because, but 0 is nothing, so yeah, obviously nothing got 3 in a row and won. So I'm gonna set here, if 0 isn't the one who won, so either 1 or 2, cheese or cracker won, not the board itself has won, then we exit out of the game. Go here, we have the board, we can't move anywhere. You do bam, still can't move anywhere. You do bam, still can't work anywhere. You do bam, still can't move anywhere. You go bam, cheese wins, now you can go. And you can see that the board game actually stays there, which is quite interesting. But that is obviously not what we want to happen. We want to get rid of the board and clean up all the things there. Or we could keep it there if that was something we wish to happen. And actually, if we click on the interactable zone in the back, which will actually work here, if you click here, you'll notice that nothing is happening. Ian is just walking there, like if there was something there. And so if you click here, it's the interactable zone you actually click on. If you click on the interactable zone and interact again, you can continue playing. So, you know, that's it's not ideal. That's not ideal. The reason we could still play actually is because the grid got cleared when we reacted again. And yeah, here, because we create the grid here. So it actually recreated the entire thing. Anyway, what we want now is a way to get rid of everything. So we're gonna do that now. I'm gonna add, I like to add it at the end, like even under everything, you know? It's gonna be a little function cleanup. And here we're gonna remove everything. So this is interesting. There's many ways we could do it, that we could get rid of everything. I'm going to take the slightly more complicated way, but I like this way more. So what I'm gonna do is create one last list. I'm gonna call this list entities, have just a big old list of them, and I'm gonna add I'm gonna do what I did with the grid tiles basically, except I'm gonna do it for the cheese and the cracker. So for the cheese, but here it's just entities, just like that, just like that. And for crackers as well, except here we want cheese, and here we want cracker. Ooh, by the way, we didn't even do this here. We didn't concatenate its position. That's important. There we go. And the reason we want to do this is for this, because if not, it wouldn't find the different things, and we want to make sure we delete everything. Alright, so now we've put in all the cheese and the crackers into the entities, and all the grid tile entities into, well, all the tiles into the grid tile entities. So now what we're going to do is in cleanup, we're going to get rid of all of them. We're going to get rid of all of them. So we're going to do for I is equal to 1 table length of the grid tile entities, do this. So the first thing we're going to do is we're going to get every element, and we're going to destroy it. This removes that entity's existence, but it doesn't clear the list itself. So we do want to remove it from the list now that we said to destroy it in the game. And you can do this by simply saying that it's equal to nil. Nothing more complicated than that. I keep saving up and it keeps popping it back up, I'm sorry. And then we're going to do it again for all the entities like this. And just like that, we're done. Good. So that's our cleanup, and we want to clean up in the same time that we're putting everything back to normal, which is over here. Just put the cleanup, and let's test. So we click here, Ian walks, he interacts. We can play TicTacToe, so TicTacToe. And we won, and we interacted instantly after. Oh, and Crackers is starting first now because of the way it's programmed. So basically the values, they keep their values. So you might want to like reset all the values and stuff to what they're supposed to be as well. But yeah, nonetheless, you can see that this all works. Now that's a bit fast, I find, as a kind of like, oh, it's gone. So you could add a timer or something like that. But if not, this is pretty much, you know, where I'll add the timer. I'll add the timer, and I'll also reset the values here. So cheese's turn is equal to true. That should also be in the cleanup, I think, or the reaction or something at some point, because this should always be true when the game starts. Other than that, yeah, nothing else is really worth, like, because the grid, we would reset the grid as well for the game, but we create the grid at the start. So it could also be like a thing we do at the start, where we say that it's cheese turn is equal to true when we start playing the game. But you know, whatever, you know, it's not important. We can put it at the end, at the start, both places, you know, whatever we feel like. All right, so last thing I'm gonna add is a little timer before it closes. But yeah, let's add the timer, and then I'll end the video there. So here I'll create a little timer equal to 0. Maybe I equal the timer to 0 at the start too, or at the end when we clean up. And what I want to do is check the little winning condition here. I'll add has 1 equal to false. So once somebody has 1, they'll be set to true. Another thing that we want to make sure that we clean up or set at the start, so that could be either or, wherever you prefer. And so has 1, we're gonna put it where all of this is. So sorry, not all of that, where all the winning happens, over here. So here has 1 is equal to true, and then all of this we'll take out, and in the update over here we can just put it at the start or something, wherever. If has 1, then well, not that right away, that would just do the same thing. Timer is going to equal itself plus delta time. This means it's going to add up 1 a second, so it's an actual timer. And let's say after, I don't know, let's say after the timer exceeds 3 seconds, then we'll set Ian to playable and all that jazz. So let's try that out. So we can click that, we can click here, Ian walks, he clicks that, we can play, and once we win, it loads out, and we don't even re-interact with it even though we've clicked on that. Excellent. I think 3 seconds was a little long. Maybe 1 second is all you really need. A second is quite long. There you go. We've just programmed an entire minigame with scripting. So now I can click here. There might be one last thing to add, and that's if nobody wins, like, oh, well, no, I won there. But if nobody wins, like this, now there's literally, the game is soft locked. You can't escape. The game is literally like stopped. So here we could check if every tile is equaled to if it's not equal to 0, if no tile is equal to 0, not even 1, well then we can say that player 3 won, which, you know, or to say that nobody won, you know. So here, let's say we'll actually end with that. So if 3, no one won, or something funner like it's a tie, we can detect that over here if the check if 1. We'll check one last win condition basically, which is gonna be similar to these ones over here. I'll make it the first thing. So here, I'll remove all of this because it's kind of in the way right now. And it's not gonna work the same way. Yeah, there we go, okay. So we're gonna go through all of it, and here we're gonna set a variable called no space is equal to true, and if grid I j is equal to 0, then no space is false because there's obviously a place we found a 0. And in that case, we can say here, if no space, then win 3. So I'm just setting 3 to be like nobody won, or maybe I can put like -1 or something like that, whatever. I just set 3 as my number. Alright, so with that, we should be finished. Everything should work. There's some optimizations. I could add like a break here to be like, oh, we found one. There's no need to continue searching for any. Things like that. And this is obviously just like nothing advanced. It's just to show that it can be done. And it's a mini game. It's not like you need every inch of optimization here. But yeah, so yeah, let's end. You know, here, oh, Cracker's gonna, oh, Cheese blocks him, and then Cracker's all like, oh yeah, well, I'll block you from winning, and Cheese is like, oh, well, I can still win here, and Cracker's like, no, you can't. Oh, did Cracker win? Well, I just outplayed myself by accident. Okay, well, yeah, so let's just try. It's a tie. That's interesting. If you do this, it says it's a tie. I guess I was doing my outro a bit too early, wasn't I? Oh. Yeah, I probably don't want that to be there. I want that to be there, right? Yeah. There you go. I think it was just because it was in the loop. Yeah, it was in the loop, so it was checking at every colon. So now... if I do that, okay, now everything's good. It was just a little mistake, sorry. So Cracker can stop you, then Cheese can be like, I don't know, I'll stop you. Cracker's, what do you mean Cheese won? How am I not seeing this? Okay, Cracker, Cheese, Cracker. I'm not good at, okay, Cracker. No, Cheese. 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 Cracker. Cracker won. You're right. How am I so bad at doing ties? I'm just gonna play like a normal person. Cheese, Cracker. Cheese, Cracker. Cheese, Cracker. Cracker won. Jeezums, can I not even play like TicTacToe? I'm outsmarting myself. I'm just trying to test if you can. Okay. Then you want a Cracker here, let's say. Cheese's turn. Cheese would want to do that. Cracker. That's like a losing move right there. Cracker would do this. I'll place Cheese here, place a Cracker here, place Cheese here. It's a tie. Everything works. Excellent. Oh my goodness, I can't believe how many wins I was doing on myself. So it works, and if we go back, of course, everything is reset and we can play anew. So that's excellent. All right. So with that, now that everything works, everything's done, we've just written 266 lines of code about, you know, lots of spaces, so a little less, but yeah, just about 200 lines of code to write TicTacToe. in the Televoid engine itself using Lua Scripting, everything integrated. Lots of math. So yeah, that's my little devlog for this week. That's why it took a bit longer, because it's like a tutorial thing. A bad tutorial, but whatever. I hope you enjoyed. I hope you've been a little enlightened on how the scripting part of the engine works. Next week I'm gonna be showing you how some of the navigation works. I'm gonna be adding some new stuff for that, and for just like placing items and maybe a bit of item puzzles and stuff like that too, you know? Some memory puzzles, I don't know. So, I hope to see you next week with some brand new stuff. Alright, have a good week.